Hello guys, welcome to another lab report. It's been a long while, but I figured it's time for a little update for you guys. What you can see here is a little experimental setup that I have here on my table in my tiny apartment in Cologne. And in the middle of it all, you can see the linear regulator that I've been working on over the course of this week. And here you can see the lab power supply that I presented in the last video. Now, normally this whole board here belongs inside the enclosure, but well, during this experimental phase I still have to change things in the circuitry, and that's why I'm having it here outside of the enclosure, but it's connected to the transformer inside, so it should work just in the way it would work if it were built in. And the other things that you can see here is a dummy load and another power supply that is just an auxiliary power supply for the relays on the dummy load, so that does not play any role in this experiment. And the dummy load is right now switched to its maximum setting, that is about 10 ohms, around between 9 and 10 ohms at a maximum power dissipation of 500 watts. And that power dissipation, of course, is a function of the input voltage. And what you can see here is one DMM that measures the DC across the load, and here you can see the current in amperes flowing through the circuit. So if you multiply the two, you have the actual power dissipation across the load. And well, over here we have an old oscilloscope. You might remember that a couple of months ago I actually repaired a backup oscilloscope that I had brought to Cologne for experiments that I would do here, but that oscilloscope broke last week again. The high voltage power supply for the cathode ray tube broke. I guess that it was also damaged during the transport, and well, it was overloaded. Maybe we'll repair that at some point, but I don't know. So this is the backup of my backup unit, another like 45-year-old oscilloscope, which I just found out is also broken. So I hoped to measure the regulation of the voltage across the load. So what you would see here is the remaining AC superimposed to the output voltage, if you want to call it that, but it doesn't work, so don't pay any attention to these readings here. So here we have a close-up of the most important section of this experiment, and that is of course the regulator itself and the dummy load and the multimeters. And here are a bunch of clamps where I have temporarily connected two ordinary potentiometers. The left one is for the voltage and the right one for the current adjustments. And later on these will be replaced with these more expensive 10-turn potentiometers that allow you to set the output voltage with a much finer adjustment. And the current limiting at this point is not yet working very well. It works within certain ranges, but well, the circuit still has to be optimized. But the voltage stabilization is already working quite well, and right now it is set to 0 volts. And let me just adjust the output voltage here. I stop at around 4.78. You can see there is still some fluctuation, but one thing that at least works quite well is the adjustment between really 0 and around 30 volts DC. But if we, for example, let's set this to around 15 volts, you can see it's quite hard to adjust the voltage within such a wide range with a simple potentiometer. 15.2. And if I now take away one of the parallel resistors here, you can see that there is a mild fluctuation in the output voltage, but the stabilization works okay. That is a larger jump of around half a volt. No, that shouldn't be. But see, this is the kind of fine-tuning that is still happening in the circuit at the moment. And well, if I turn all the load resistors on again and adjust this to the maximum output voltage. So you see across the bulk capacitors we have around 36 volt DC at this kind of load, and we have a voltage drop then of around 5 to 6 volts minimum across the power transistors, and at this point a maximum output current of around 3 amperes. So we're talking about a loss across the transistors of around 30 watts, but the voltage stabilization works well at 30 volts and below. So at this point we're talking about, if you multiply those two values, around 100 watt of load. And of course, as long as the output voltage is relatively high, the power dissipation across the transistors is relatively low. So this heatsink remains kind of cold. And well, as I said, the current limiting doesn't work really at this point, and I still have to optimize that circuit. And I think that I'll be able to do this and other things in the next couple of days, involving adding some fans to this device so that the transformer as well as the heatsink can be cooled down, and so that we can operate all of this at a higher output power. Then of course the 10-turn pots. And one more thing will also have to happen, and that is that we modify one of the two meters so that we can use it for a current reading. One of it will display the output voltage of the linear regulator, and the other one will measure the output current. And in order to do that, we will open the enclosure of one of the meters, change the scale and the voltage divider that we will find inside. And well, that piece of information will help you to use basically any old meter that you can find anywhere to measure whatever you want. I did something similar in an earlier video, but we will sort of repeat that lesson. Okay, so now you know that I'm working on this and that it's not yet totally completed, but there will be a video about this thing soon, and I will wrap that up, and then we will start to work on that second power supply that involves some switching converters. Okay, so that was about the very near future of this channel, but there have also been a couple of parts arriving here that will play a role in the more distant future of this channel. And well, it'll still have to be decided what is going to happen in the end, but the plans are clear. So I have a bunch of boxes here, and I haven't looked inside them myself, and so this will be interesting for the both of us. So here is the first box. I just won these auctions here on eBay. And what should be inside is a couple of electric motors. So here is the first of them. And another one. I wonder if there is more in here. Okay, that was box number 1. There's the second box, also very heavy. And we have one more motor. And yet another one. And here we have a third box. And this is another part that belongs to these electric motors. And I'm pretty sure that most of you have never seen anything like it. And that is because this is a very rare and special item. And here is package number 4, the only one that I actually opened before. We have another very heavy part in here. Okay, So let's talk about what these things actually are. Okay, so we have a couple of things here that you will probably never see if you're not either are an apprentice here in Germany, for example, for a special kind of electrical engineering job, or if you're actually studying electrical engineering at some kind of institute of higher learning that also happens to have a more practical focus. So let's just start. What you see is obviously an electric motor, and by the fact that we have this transparent plastic ring here, you can see that it was made for educational purposes. You can look inside and see that there is a commutator and some brushes there, and that should tell you that this is either a DC motor or a universal motor. And when we take a look at the front, we can see that there are actually labels on here, in different languages even, and that tells us that this is a Gleichstrom-Nebenschlussmaschine, or as it says, shunt-wound machine. I would call this a DC shunt-wound motor in English. And well, it is somewhat similar to the kind of universal motors that you might know. We have seen that, for example, in my washing machine motor videos. But the difference here is, among maybe other minor things, that the field winding and the rotor winding are not connected in series but in parallel, which gives the motor a different kind of behavior. And we can then take a look at the next little motor here, and that actually is a universal motor, or Einphasen-Reihenschlussmotor is the correct German name for that is, and that means single-phase series-wound DC motor. So as you can see in this educational program, they didn't see a need to even differentiate between a universal motor and a series-wound DC motor, and that is because the differences between these two types of motors are minimal at best. The other two motor types have a completely different outer appearance, and that is because they are induction motors. Here it says, I don't know if you can read that, it's kind of hard to find the right. It says Einphasen-Induktionsmotor Spaltpolmotor, and that means single-phase induction motor, shaded pole induction motor, and that is what this is. We have seen shaded pole induction motors before. For example, the little motors that power fans inside microwave ovens, those are almost always shaded pole induction motors. And I've talked about that in one video before. The fourth motor that we have is also an induction motor, but this is a single-phase induction motor with motor capacitor. So yet another induction motor that was designed in order to run on single-phase AC. And these are the four motors that I was able to buy because I won those auctions. Actually, someone auctioneered also other more special types of induction motors, but I wasn't able to win the auctions, unfortunately. This fourth part here, or fifth part, which was actually much more expensive than the motors themselves, is a so-called magnetic powder or magnetic particle brake, in German Magnetpulverbremse. And as you can see, the motors and the brake form a system that was used in these electrical engineering schools in order to teach the physical differences or the differences in the behavior of the different types of motors in use in the industry. Now, well, DC motors like that are very rare these days, and that is why it could be interesting for us to connect other types of motors to this brake. For example, brushless DC motors, stepper motors, three-phase induction motors, and so on, and that is something that I want to do at some point in the future. Let's take a closer look at this brake then. This is a technology, by the way, that was used or was invented in Germany, and which is a typical kind of brake that you can find in motor test stands for electric machines, as you have here on a small scale for educational purposes. And well, let's read the nameplate here. And there we have a reading for the maximum speed or rotational frequency that this motor is rated for, and also a torque, which is the maximum torque that the brake can apply. And down here, as if I see that correctly, we have some kind of optical sensor that is probably used to measure that speed. And what this magnetic particle brake actually does is that it is an electronically controlled or a current controlled mechanical dummy load that can be used in order to apply a controlled torque to the motors, and that will enable us to measure not only these motors here, but other motors that we can salvage from parts. And I hope that that will help me to investigate even further how these motors could be reused in an optimal way. Now, all of this stuff here cost me a lot of money, and it didn't get much cheaper by the fact that I bought this part here, which is another magnetic particle brake. But other than that one, that is rated for 2 Newton meters maximum of torque. This brake here is a professional industrial magnetic particle brake rated for 35 Newton meters max. And see, this will take a while, months, maybe a year, I don't know. But what I'm planning here is to build a motor test stand to use in my videos. And the first objection maybe will be to familiarize myself with this educational material here. And these are things that I don't really need for myself. I bought this just to make educational videos in which we can explore the different behavior of the different types of electric motors. And what I will have to do is to figure out which kind of sensors are here already, what kind of voltages I need to power the brake and so on. So a power supply will have to be designed especially for this brake. And this stuff on this table here has cost me, well, around 500 euros. And this is the kind of stuff that is only possible because of the Patreon supporters. And a special thanks to you there. And what you have to know though is that this company LW, that is ELWE, is one of the few companies in Germany and probably in the world that makes equipment like this. And a complete motor test stand with different types of machines, the magnetic particle brake and the electronics needed to power the brake, the motors and measure everything costs about 15 to 40,000 euros. So, well, paying a couple of hundred for this kind of equipment might be a good deal then, even though it is maybe 30 years old or older. And, well, I know that people are going to ask when is it going to be finished. I can't tell you at this point. And that is also because this is the kind of thing that I probably will only be able to realize in full scale once I have found a new workshop, because this apartment, of course, is not sufficient to operate anything like that. It would be kind of silly to build something like a large motor test stand in here. But, well, that's another topic. Maybe we'll talk about that in just a minute. And here's another thing that I want to talk about briefly in this video, and that is that I have gotten another package from rural Illinois, and it is from my old friend Renoa. Now, we have been in contact now for, I think, maybe 2 years, I'm not sure. And I have gotten stuff from Renoa before, and I'm always happy to see that something new has arrived. Okay, so there is a letter inside, and let's read that before we take a look at the objects inside. Hello TPAI. Here is a book from 1944 I bought just for you almost a year ago. And also an antique folding ruler of mine. The ruler is in rough shape, but it is about a century old after all. I carried it everywhere I went for about 8 months, but I became afraid of breaking it. Also, its use of imperial units wasn't very helpful, since I use metric more often. Did they have similar folding rulers, but with metric units over there? I've wasted a lot of time trying to practice ways to flip the ruler out in one motion. I haven't found a nice way to do it yet. Perhaps you can find a way to unfold the whole ruler with a single motion. Okay, so let's take a close look at that. Seems to be made of some kind of wood and some brass parts, some hinges. It folds out like that and like that. So I get why it could be hard to unfold this with a single motion, and I don't know if I will manage to do that. Yeah, in this, I guess these are inches, right? Well, certainly don't use inches too often, but it could help me to get a better feeling for the American system. And that is kind of important since I have so many American viewers. Okay, as for the book, I thought of you as soon as I saw it for sale. I think you might like the illustrations in it. That artwork you made a while back was very nice. Feel free to cut the pages out of this book for artwork if you want. It's really cool that you are able to still live in Köln. It looks like a very nice city, and several people I knew have mentioned it is a lovely place to live. I hope 2017 is a great year for you, and I look forward to your future videos, Renoa. Sent from my 1955 Royal typewriter. Okay, so thank you very much for that, Renoa. I hope that 2017 will also be a great year for you and for America. Okay, so it's called Hand Tools Navy Training Courses. Looks really like kind of right up my alley. This is from inside 1944. I actually have a book like that about lathes from that exact time. And it was also back then printed for the Navy. As far as I know, they sometimes took books that were already or that already had been published on the market before. But when these books were especially good, I guess they reprinted them for the armed forces, because of course there was a greater need than before for these kinds of things. And we see some really lovely illustrations, kind of cartoonish, more cartoonish than what you would find in German books of that time. But you can see that the paper quality is quite good. It's still very bright and not very brittle for paper that old. So even though it was 1944, it seems that there still were some resources to make good paper. And some kind of security advice here. And I don't think that I will cut anything out here, but maybe I will make some scans and then maybe we can use that as illustrations for my channel later on. So thank you very much, Renoa. And well, there's maybe only one more thing that I want to talk about. Hello guys, so I might look a little unhealthy or downtrodden at the moment, and that is because I have spent so much time back in the basement in the old workshop, because I really threw away a lot of things in my final preparations to really move away from that old house. And well, I was subject of a lot of dirt and grime and stuff that I might be kind of allergic to. That's why my eyes looked so screwed up. And that's another thing that I really want to talk about, and that is that I'm now actively looking for a new workshop space here in the vicinity of Cologne. And well, kind of bad luck, I actually wanted to visit a place just yesterday, but the person that I was in contact with was really a big idiot. You know, they had put up like an ad for that place that it's open, and well, I talked to the guy, and even though I'm quite sure that that was like an adult person of maybe 50 years of age, wasn't able to tell me his name, give me a phone number, and wasn't able to make like an appointment for a meeting within a week. And so I drove to Cologne because I wanted to visit that place yesterday, but the guy wasn't answering anymore, even though the ad is still up. So it seems that for some reason he's unable to let me in or whatever. That was one thing that really didn't work too well. Another thing, while I was driving to Cologne, I lost one of my license plates. Now you might think, not a big deal. Well, it's a big deal in Germany, because you cannot just reprint or remake a second license plate and go on. You have lost a license plate, and that means that someone else could use that on his car and do, like, I don't know, criminal stuff with it, whatever. So I informed myself, and what you actually have to do is, if you think that it was stolen, you as an owner of the car have to contact the police about that. And at least if you don't think it was stolen, as in my case, you still have to contact like the traffic office. New license plates have to be made. The old number cannot be used anymore for 10 years, and new paperwork has to be done, and that'll cost me around 100 euros. So I wasted about, for back and forth, about 60 euros in form of gasoline, and then another 100 bucks simply for losing my license plate. And on top of that, the entire reason why I came to Cologne was to take a look at that potential new workshop space for me, which I didn't see. So yeah, really kind of a bummer. A lot of bad luck lately. And so just that you guys know, a couple of weeks back I was asking for your help in order to find this place here, which I'm very happy with, at least for living, not so much for making videos because it's so small. I'm now officially looking for a new workshop. So if you live around here and you know someone or you have something yourself, please contact me under inventordonations@gmail.com. And please send me an email. Do not write this in the YouTube comment section, and don't send YouTube private messages. I'm flooded with that kind of stuff. Most of it is just a lot of spam that I receive all the time, and that is why I have a hard time keeping up to date with the comments and the messages. Just send me an email and then we can talk about this kind of stuff. And in German again, ich suche jetzt aktiv nach einem neuen Ort, nach einer neuen Werkstatt in Köln oder in der Umgebung. Kann 20-30 Kilometer weg sein, kein Problem. Wenn ihr irgendwen kennt oder selber was habt, dann schreibt mir unter inventordonations@gmail.com. Bitte schreibt das nicht in die YouTube Comment Section und bitte keine YouTube Nachrichten. Okay. So I hope that maybe someone has something, otherwise I will just take the usual route, go online, look for something, and if I can, I will show you some footage of the potential new places, and maybe I will also show you, or certainly I will also show you the old place, because we never made a walk around there, and if I really showed you what the house looks like, and we will do that maybe after I have left there, so that you have a comparison. Okay guys, so I hope to see you in a couple of days when that stupid lamp power supply linear regulator is finally 100% operational, and until then I hope that you have a good time.